It's a privilege for me to address this distinguished audience as the guest of honor. I extend greetings for the new year to all the participants in this wonderful conference and bring to you a realistic hope, a realistic message of hope for the future, though 2020 was a forgettable year for a lot of us. Around this time, as Sanjay said, I write an annual paper, and last time I called it the tipping point because I expect the world to tilt. And the world did tilt, as a result of which we saw so many lives lost, livelihoods lost, businesses hit, some damaged for good, some limping back, and a few actually thriving because of this massive tipping that has happened. I want to use the next 10-12 minutes to explain how this tilt that the world has had is going to be advantages for. Okay, so all I want to say is that the world is tipped, and on account of the fact that the world is tipped, there have been lots of changes that has happened, a lot of suffering, and a lot of good things are going to happen in the future too. There are many unsolved big problems, which as I explained, have been postponed by kicking the can further down the road. It is not possible to do that anymore because there's a deep sense of urgency now in the minds of business leaders, in the minds of politicians, people at large. If it is seen to be urgent and big, billions of dollars will be spent on it. That may not have happened 2 years ago. So the question to you is, how do we approach solutions to these big problems, big and urgent problems? More research, more capital investment, more brainstorming, more conferences like this? Probably not, because these are all necessary conditions and not a sufficient condition. What then is the missing sufficient condition? Well, the missing sufficient condition is not lack of engineering knowledge. It's something that is available within each one of us, but we don't use it because we're not trained to use it. Therefore, big problems keep accumulating and growing each year. Take, for instance, vaccine development. There was a logical belief that a vaccine cannot be developed and deployed in humans in less than 4 years. Most vaccines actually took longer, and 6 to 10 years is par for the course. Now, it's incredible that people could actually do it in less than 1 year in 2020. Something changed the mindset of researchers, of regulators, the mindset of volunteers for trials, and even vaccine manufacturers. Each of them changed their mindset, and that's why we have 6 candidates already approved, and there are 244 in line. Imagine Serum Institute in Pune. It started manufacturing millions of doses of Oxford AstraZeneca vaccine long before phase 2 and phase 3 trials were completed. The vaccine chain shifted from parallel processing to shifted to parallel processing from serial processing, when the given wisdom was that vaccines have to be made serially because there are many stage gates in the process, and at each stage gate, many candidates get thrown out. So, but the world tilted so badly that everyone's mindset changed and said, hey, we have to try parallel processing because it's urgent. COVID-19 became the world's biggest problem, and soon enough, the mindset changed. There was also a mindset change at the research level, as I mentioned earlier. The husband and wife team of German researchers of Turkish origin, Ugur Sahin and Özlem Tureki, were professors at a medical college up until 2001. Then they set up a research company to work on cancer therapy. Later, they sold it and set up BioNTech in 2008. They kept looking for new types of solutions, not more of the same, or more efficient solutions compared to what was existing. They wanted a breakthrough. They thought, why not we rewrite the code of the RNA instead of tricking the immune system into thinking that there's attack by using dead viruses. 10 years later, they announced that they have a new technique called a messenger RNA or mRNA. And when COVID struck, Pfizer quickly tied up with them, and the rest is history. By the way, they are now worth $2.5 billion. Now, if that is fantastic, can you imagine what more this change of mindset from serial processing to parallel processing is set off? Many of you probably don't know that there's a project which started in August under the aegis of the Centers for Research in Emerging Infectious Diseases to get a vaccine for all kinds of epidemics in the future in 4 months. 4 months and not 6 to 10 years. They are creating a library of candidates, a huge library of candidates, which are being pre-tested now. So if a pandemic strikes in 2022, they would search the library for a similar, find it within 3 weeks, and be sure that these 2-3 candidates look good, and get it into phase 3 trials in 3 weeks' time, and get the phase 3 trials completed in 3 months. In parallel, the manufacturing would start, the distribution supply chain from the manufacturer to the affected regions, likely affected regions, would also happen in parallel. So parallel processing has become the norm. And so in the future, we may not face a pandemic of this magnitude unless the virus strain is not one of the hundreds of similars that are now being tested. Okay, so we could deal with new viruses in 4 months flat and prevent global spread. So that's radical innovation, which is possible because of the mindset change and global teamwork. So my message to you is that there's a need to change your mindset if we want to succeed big time. There is a reason why not everybody can create an Amazon, a Facebook, a Microsoft, an Alibaba, a Tesla, etc. I think there are 3 ways to change the mindset to create a new world. The first is getting rid of the shortage mindset. Allow me to take you back to India in the 60s. On the one hand, there was a shortage of almost everything, be it rice or milk or wheat or fruits or whatever. And on the other hand, the shortage of industrial raw materials, consumables, finished goods, capital goods, logistics facilities, and investable funds. So the 70s and 80s were not much better, but what all this did is to create a permanent imprint, almost permanent imprint in our mind of shortage. Even though we had a liberalization, economic liberalization in 1991, that shortage mindset still rules our mind. It makes us set unreasonable constraints before we start a journey of problem solving. We as engineers, we are taught to think like that. You know, there's a shortage of resources, of talent pool, of money or time, and we call them boundary conditions. Or some people call it realism. It's this kind of shortage mindset which creates this so-called realism, which prevents us from finding breakthrough solutions. It prevents us from seeing what could be done if these constraints didn't exist. So this is a global problem. It's not just India, but it's much worse in India for reasons which I explained. But this shortage mindset can be overcome if you consciously practice to challenge it every day. It will disappear. Take another example, water. There's going to be a great water shortage in the world. In the next 3 years, 22 cities in India are going to run dry. Agriculture, and that includes Hyderabad, by the way. Agriculture is going to face challenges. It will be difficult to set up new process plants in India, even if only modest amount of water is required. There is scope to reduce water consumption in agriculture by 50 to 70% by using various techniques. There's scope to get close to net zero water consumption in many manufacturing plants if we put our minds to it. There's drinking water shortage problem, but for which there are many solutions being tried out. I don't want to get into that right now. Of course, you must take up these challenges as chemical engineers. But let's go beyond that and understand why there is a shortage. You know, we are only using 3% of the water on our planet and in our atmosphere. And therefore, we are constantly trying to divide that 3% amongst various potential users. And as the demand rises, we try and find more and more efficient ways to conserve that 3%. It's not increasing. What if we were to focus on the 97% water, which is not utilizable at the moment? We may not have to waste time dividing what we have. Instead, we may have a very green planet with deserts receding. So stop thinking of a shortage and figure out how to tap at least 10% of the 97%, and you'll create a new world. Professor Belfort, who spoke a little while ago, gave us some ideas on how membranes can be much more efficient, probably several times much efficient, and the cost of desalination might become very, very low. And then there's no problem of getting all the seawater. And if we get the seawater, we're going to get a lot of marine chemicals on the side. Okay, so it's all about the kind of research which Professor Belfort talked about. Find a breakthrough to get desalination to become dirt cheap. You might think it's not possible. We also thought this about our telephony in India. It was hugely constrained and expensive, but today the bandwidth has become plenty and almost free. It took someone with a different mindset to change it all. Left to BSNL and MTNL, we would be not attending this conference today online. Likewise, we have lived through centuries of shortage of energy. When there are so many chemical engineers around, why can there not be a complete mind shift change from energy shortage to energy surplus? I know it's easy for me to say that, but I'm just presenting a challenge in front of you. You know, the sun casts 430 quintillion joules of energy per hour on the earth. That is 430 into 10 raised to 18. Do you know how much energy is used to manage the whole earth? Just 0.01% of that. So imagine the amount of energy available. But we yet spend all our money, a lot of our money on, we have spent in the last 50 years, a lot of our money on researching how to capture more and more fossil fuels since they're depleting at the higher levels, and we're to go down into the sea, go sideways and all kinds of things. This weakness of ours has been exploited by strategists in the OPEC. Whenever they saw research dollars going into alternative energy research, they dropped the oil prices just a little enough, and lo and behold, funding for alternative energy stopped because renewables didn't seem economically exciting in the short term. So we have to get rid of the shortage mindset. The second way is to change the paradigm. The vaccine is an example of how a paradigm was changed. We always think that there are good solutions within the existing paradigm, so we keep working within it. There are many more problems that can be solved if we get out of it. I will not talk about EVs replacing IC engines. That's an old story. We know that pesticides is a huge problem. We are trying hard to reduce the problem by 30 to 60% by genetically making certain crops more pest resistant. Agricultural scientists know that when pesticides are sprayed, about 33% fall on the plant. The rest falls, where? Falls outside. But do you know that actually 1% of all the pesticide that is sprayed actually gets absorbed by the plant? Much more may be falling on the plant. Only 1% gets absorbed in the plant. The remaining 99% pollutes the food chain, the rivers, the lakes, etc. And we have a big problem. The world is desperately looking to you for solutions. Now, there's a certain Dr. Greg Lowry at Carnegie Mellon who has developed gold nanoparticle coating for crop chemicals and nutrients, whereby the crop chemical can now go straight through the stomata on the leaf into the plant. It slips through the two stomatal guarding cells, which prevent anything from entering the stomata. Okay. Now this, with the gold nanoparticles, you can trick it to allow it to enter. Now this has been established in the lab. Now you chemical engineers can design and manufacture nanoparticle coating systems, application equipment, protocols, etc., and thus solve a huge human and environmental problem. Are you ready as engineers to collaborate with research labs to take this into the field? Now, talking about gold nanoparticles, the Biosciences and Bioengineering Department at IIT Bombay developed technology to kill cancer tumors by transporting gold nanoparticles into the tumor on microscopic scaffolds and then heating them up using a laser beam on the tumor. No chemo required, no radiation, and this will be just a treatment in the OPD of a hospital. 20 minutes, 2 sittings. Now, it will have a huge impact. Now, are you prepared to develop and design and develop manufacturing devices which will actually help to deliver this? If you're ready, there's a great opportunity waiting because a lot of dollars will be spent. But the third approach could be to cross the domain of knowledge. If you look beyond your core domain, you can borrow and adapt knowledge from various diverse areas. We saw today, the whole lecture by Dr. Belford was about biotechnology. He's a chemical engineer. Crossed over and picked up knowledge there, and he's now developing, using chemical engineering to do amazing things. So there are lessons to be learned from textiles, from biotechnology, from physics, from material science, from data science, from artificial intelligence, virtual reality, and a whole lot of digital technologies. So if you look beyond yourself and your team for formal and informal partnerships, you can make stunning innovations. Unfortunately, there's time only for one example, and that's what I'll do before I stepped off. There's something in swimwear that can set you thinking. Hundreds of swimming records have been broken in the last 10 years by wearing Speedo's fast skin because it reduces the drag. Fast skin uses fabric whose surface has been modified at the microscopic level to resemble the skin of sharks. The Speedo partnered with textile innovator HiQ Partners in Switzerland to get this technology to make fabric of that kind. Can you not borrow the idea to create nano patterns on the surface of heat exchangers and make them super efficient? That means that either the plate does faster heat transfer and therefore the process is more efficient, or the size of the heat exchanger could be reduced. So less metal use, ore ore mined, less energy, less pollution. Quite a breakthrough in the making. I will stop here because I have full faith in the creativeness of Indian chemical engineers who will think of 100 more ideas. If you change your mindset and dare to dream big from today onwards, I will feel that the purpose of my talk has been fulfilled, and India will have a lot to thank you for in 2021 and beyond. Thank you.